Let us look at the graphical analysis of motion. So this is a method that can be used to describe the motion of a what of an object in terms of what of curve instead of what of using by algebra what equation. So, and the graphical analysis of motion, it exists in four forms. The first one is what we have distance against time, we have displacement against time, we have speed against what against time, we have velocity against what against time. So that is the what what you can now what analysis of motion. So this is the method used to describe the motion of an object. Yes. Instead of using what algebraic what equation. So I said this can be exist in four forms: distance time graph, displacement time graph, speed time graph, and a velocity time what graph. Let me start from the what from displacement time what time graph. The first one is what this distance time graph. See, in this distance time graph, here we are plotting graph of distance against time. We are plotting graph of distance against what? Against time. Whenever you are plotting graph of distance against time, the slope or the gradient of the curve is a what? Is a speed. The gradient of the curve is a what? Is a speed. Let us look at it now. I having a graph of this. So this axis here is a what? Distance in meter. And this axis here is time in what? In seconds. No, I'm going to draw what two graphs here. We have what? Time. And the vertical axis here, we have what? The what? Distance. Good. In a graph of what? Of distance against time, we all know that automatically for this graph, our slope or gradient is what? Is speed. Because it is speed that is the ratio of what? Of distance with what? With time. So if I now draw the graph in this form, my graph is what? Is a straight what? A straight line. Abi? If graph is a straight line, and by drawing the what? The curve, find the slope of the curve. This place will be what? Change in t. Here we have change in what? The what? Distance. Abi? Like I said earlier, that what? The slope of this curve, the slope will be equal to the what? Speed. The slope of the curve will always be what? It is speed. And if you draw the curve in this form, this is not a straight line. But to get the slope of this curve, we need to draw a what? A tangential what? Tangential line. So if you draw the tangential line, you will draw it in this form, and through this tangential line, you will get the what? The gradient of the what? Of the curve. Where this place is what? Change in d. Here we have change in what? T. And the slope for this curve will be what? Will be speed. Because it's the only speed that is what? It is change in distance against time. And what will be the name of this graph now? Whenever you are plotting graph of distance against time, and then we have a straight what? A straight line. Please don't disturb yourself. The graph is what? Is uniform what? Uniform speed. Uniform what? Speed graph. Why? Because we are plotting what? Graph of what? Of distance against time. And is what? Is straight. So that's what I said for uniform speed. The distance change with time is what? Is constant. Because distance change with time here is constant, that is what is straight. But distance change with time here is not constant, that the graph is what? Is not straight line. So in the graph of distance against time, and we have a straight line graph, we call it uniform speed graph. But the graph of what? Of distance against time, and the graph is what? Is curve. Is curve. It's not straight line. We call it what? Non-uniform speed graph. So, but in the case, the next one is what? Displacement time graph. Displacement time graph. Displacement time what? Time graph. For displacement time graph, so for displacement time graph, we have this in vertical, and we have for the second one, so in this what? Vertical line here, here you know we have distance here. This place will be what? Display what? Displacement in meter. And this side will also what? Displacement in meter. And here will be what? Time in seconds. We also have time in what? In seconds. So if they now draw the graph, and the graph is what? A straight line in this form. And the graph for this one is what? Is curve like this. So like I said, whenever the what? The graph of displacement time graph is a straight line curve. The graph, the title of the graph, it will be what? It will be title of the graph, it will be what? Uniform what? Uniform velocity graph. Because if you find the slope, the gradient of this curve, the slope will be give us what? Velo what? Velocity. It's the change in displacement against time. But here, to know the curve here, you can pick any point here. So the point you pick here, you will draw a what? A tangential what? Line, which will touch the curve. So the line touch the curve, you trace it like this, like this. So if you trace the what? The curve in this form, is the change in displacement here, change in what? In time. Likewise, change d and what? Change in what? Time. So if you now look at what? The gradient here, gradient is the same thing as what? At the slope, it will give us what? Velo what? Velocity. So please, in multiple choice question, what you need to consider most is what? What do you have in the vertical axis? If the graph is a straight line and distance against what? Time is uniform speed. Graph is a straight line, but it's displacement against time, uniform velocity. But is what? It's displacement against time. But the graph is not uniform. It's not straight line. And displacement here, time here is what? Non-uniform what? Non-uniform velo what? Non-uniform velocity. So at this point now, this curve tells us that what? The change of displacement with time is not what? Is not constant. Change is not what? Is not constant.